Hello everybody, welcome back to Maths. Hope you're doing good, hope you're doing well. In today's session we're going to be taking a look into highest common factor, lowest common multiple and Venn diagrams. Now we're going to start off really slow with highest common factor, lowest common multiple, but there are some exam questions which require you to use a Venn diagram, so we'll look into that as well. So if we're doing some basic highest common factor, it will be something like, I don't know, let's say we've got the number 20 and we've got number 25, and we just need to work out the highest common factor between these two numbers. So what do? We need to say, well, let's pick some factor pairs. So let's always start with the number 1. So it's going to be 1 times by 20. After 1, let's try 2. So we've got 2 times by 10. Let's try 3. 3 doesn't go in there. 4 does, so it's 4 times by 5. And then that's all the factors, so we can stop. Let's do the same for 25. We have 1 times by 25. 2 doesn't go in. 3 doesn't. 4 doesn't. 5 does. So 5 times by 5, almost said doesn't then. So 5 times by 5, and that's where we stop. So what is the highest common factor between these two numbers? We can see the largest number quite clearly is 5 in both lists. So we say the highest common factor is 5. And this works for all the numbers, but sometimes when it's a really big number, it can be quite challenging. Hence why we need to use Venn diagrams. So let's take a quick look at the lowest common multiple. So let's say we've got the lowest common multiple between 6 and let's say 8. So let's just list all the multiples of 6. So let's say, I say all the multiples, let's list some of them. So 6, 12, 18. Now I don't necessarily know how far I want to go here, so I'm just going to keep going. I might stop there, for example, but I'm going to go 8, 16, 24. But in this second list, you need to stop as soon as you see a number which has appeared in the other list. So clearly 24 and 24 there. So we can say the lowest common multiple is equal to 24. So that's all you need to do with that. And these two techniques work really, really well when it comes to lower or numbers. But when it comes to larger numbers, for Venn diagrams, you need to use Venn diagrams because that makes life a lot more easy. However, before we do that, I want to make sure that you guys can do prime factor trees. So sometimes we call this prime factor decomposition. Sometimes it's just list the prime factors. So I'm going to show you the differences between the two of them. So let's take the number 60. We want to split this into two numbers, and one of the numbers cannot be the number 1. Doesn't matter where you start because it all filters out at the end. So you could choose 2 and 30. What I prefer to do is choose something like 12 and 5, where the numbers are fairly close to each other. For example, 2 and 30, those numbers are quite separate from each other, but 12 and 5, they're a bit closer together. The reason for that is if I had, let's say, 2 here and 30 here, then all the numbers filter down this way and this branch stops, whereas this way is just a little bit neater, but it does not matter at all. Anyway, 5 is a prime number, and as I say, that's a kind of backtrack because we're going to stop there. Anyway, 5 is a prime number, so we circle the prime numbers. And number 12, what numbers make 12? Doesn't matter what you do there, but I'm just going to say 3 and 4. I can see a prime number, so I'm going to stop. And the number 4 is 2 times by 2, so we're going to stop there because we've circled all the prime factors. So we have now prime factor decomposed the number 60. Now the question might say to you, write down the prime factors. It might say list it as a product of its prime factors. That's the key word, product of its prime factors. So we're going to list all the numbers. So we've got 3 times by the 2 times by the 2 times by the 5. Okay, but then what we need to do is we can list them in order. It doesn't necessarily have to do that. You'll still get the full marks, but it is a bit nicer. But we can see we've got 2 times by 2, and we're not going to write 4 there, but because I've got 2 of them, we have to write down 2 squared. So 2 squared, then we've got the times by the 3, and then we've got times by the 5. Now, that bit there isn't the skill that you need for the Venn diagram bit, but I'm just checking in to make sure you can do that if the question said, write down product of prime factors and write them as a product of the prime factors. So hopefully that makes sense. But what we need for the Venn diagrams is this here. So I'm only going to go through one example here, so I hope just the one example is okay. I'm going to pick fairly low numbers. I'm going to pick 24, and I'm going to pick, oh, I don't know, 30. I'm going to pick fairly low numbers just to demonstrate, but this does work with pretty much any large number. So first thing we need to do is just write down we just need to prime factor decompose 24. So we're going to say 12 and 2. 2 is a prime number. 12 I'm going to say is 2 and 6. 6 isn't prime. Then we've then got 3 and we've got 2. Okay, so that's quite nice. And then we've got all them circled. As soon as they're all circled, that's where you can stop. The number 30, let's write this as, I don't know, let's say 3 and 10. 3 is a prime number, 10 is going to be 2 times by 5, and we've listed all the prime numbers. The next thing we need to do is we need to draw 2 circles, so a Venn diagram, so 2 circles. Okay, now on top of one, we're going to write down the number 24. On top of the other one, we're going to write down 30. So I'm going to start with the number 24 first, and I'm going to cross out this 2. Is there a 2 in both numbers? Yes, there is. So because it's in both, I'm going to cross it out of both, and I'm going to drop that into the intersection. Okay? Then we've got this 3. Is there a 3 in both? Yes, there is. So I'm going to put 3 in both of them. Make sense? Then I've got another 2 in just this 24. Notice that it doesn't occur in the 30, so that's where we put this 2 just in the 24. Okay, then I've got another 2 that goes in the 24. All the 24s are gone, so that one's done. And then in the 30, I've got just the number 5 left, and just the number 5 goes in just the 30. Okay, so that's them all done. So next, we're going to write down what is the, let's get a nice colour. So what is the highest common factor and what is the lowest common multiple? So for the highest common factor, you need to multiply every single number that appears in the intersection. So in our case, we've got the number 2 and we've got the number 3. So we have to multiply those 2 numbers together, okay? Now, if there is only one number in that intersection, then that number is the highest common factor. But in our case, you can see we've got 2 numbers, so we have to multiply them. So that gives us 6. Next, for the lowest common multiple, you have to multiply every single number that you can see within the Venn diagram. So notice, I'm going to show you this in 2 ways. So we've got 2, we've got 2, we've got 2, we've got 3, we've got 5. So we need to multiply all of those numbers together. But here's the shortcut. This is the shortcut you can do. You can take the highest common factor and then multiply it by everything which is not in the intersection. Because think about it, we've already multiplied these 2 numbers together. So I'm going to multiply by 2, which I can see is 4, and then multiply that by the 5. So I know the highest common factor is 6, so I can do 6 times by 4 times by 5, and then I'm just going to stick it in my calculator because I'm lazy, and that gives me 120. So you can either just multiply them all together, or just take the highest common factor, which is the intersection, times it by those 2 numbers, times it by that, and that's all you need to do. Right, hopefully that all makes sense. Thank you for watching the video. If you found it useful, please make sure you click that like button, and also do me a massive favour and click that subscribe button, and I shall see you guys in the next one.